Good morning, student. Let's move ahead into the series of software engineering. The next part, what we are going to study is Introduction to Software Engineering. I am Dr. Alifia Jagirdar, Coordinator and Assistant Professor of BBCA Department. So in this session, we are going to cover definition of software, what are the characteristics of software, definition of software engineering, and the need for software engineering. What is software? If you see these logos, these are nothing but software. Facebook, LinkedIn, Instagram. So basically, in terms of professional language, it is a software or a product which is built by professionals and they support it over a long term. So they provide the support for the software to retain into the market. So a computer software is the product and it is normally retained by the professionals. Okay. So if I talk about textbook description of software, it is instructions, a set of instructions which is also termed as computer program that when executed it will provide a desired feature, function and performance. Data structure which will enable the program to adequately manipulate your information. The third is descriptive information. Now descriptive information can be both in hard copy and virtual form, that is soft copy, which describes the operation and use of the program. For example, you consider your phone. Your phone always comes with a guidebook where it is written in hard copy how your phone should work, what the components are involved into your mobile, what are the features. So these all are called as descriptive information. Now let's move ahead with types of software. Now there are two types of software. One is system software, the other is application software. System software is basically they reside onto the core. Okay, so system software has again three parts. One is translators. I can have interpreters which interpret my each line to the machine and vice versa. Compiler, it will identify the errors into your program and it will give the errors, it will show the errors to the programmer so that it can get rectified. Operating systems, now disk operating system which is also termed as DOS, Windows, Unix or Linux. Okay, so these are operating system on which your software sits and they interact with your OS. Next is packages. Packages is set of classes combined together, like this linker which links your library files, loader which loads the library files, editors where you can actually type your programs. The next is application software. Application software which are used by the customers. There are two types: application package tools or special purpose software. Now what is application package? In an MS Office you will have Word, Excel, right? In database you can have database management system, that is Oracle. In special purpose, I will tell my programmer what are my requirements and according to it the software are customized. So these are called as special purpose softwares. Now accounts are going to require different software. Payroll will require different type of software. Inventory will require different type of software. So these are called as special purpose software. Let's move ahead. Now this is the main section where I am going to identify the characteristic of software. The first most important characteristic is software is developed or engineered. It is not manufactured. Okay, you don't manufacture, you don't assemble the software as you assemble your hardwares. You can touch, you can feel your hardware, but software you can only see it through your eyes. So software is a design of strategies. It is set of instructions which is going to perform your task. Okay, the design can only be developed but not manufactured. On the other hand, design is just a material of hardware. I can design it. I can say, okay, I want a keyboard of this particular company, like Zebronics. I want my mouse to be from again with Zebronics and my laptop with Dell. So this is how it is called as hardware, but these are all materialistic. So it says software can be developed because I'm going to use set of instructions, or engineered, but it is not manufactured. The next most interesting characteristic is software does not wear out. That means after 10 years your software will not say, okay, I'm not going to give you the result because I'm tired. So here when manufacturers build the hardware, it says it is going to show the errors and faults, but the hardware errors and the faults can be removed by having multiple trials and errors, and we remove the defects. So when the final product comes into the market, it is ready to release and use in production. Okay, like example, excessive temperature, dust, vibration, improper use, and so on. This will wear out my hardware very fast. This will not affect my software. Okay, so wear out means my hardware will stop functioning if I have excessive temperature on it, like excessive dust is there, excessive vibration is there, or improper use of it. Okay, now if you see this, let's see what this means. If you see this curve, it is called as bathtub curve. Can you see this? It looks like a bathtub, right? So it is nothing but a failure curve of hardware. As we say, software does not wear out. So let's first see what is an hardware. So in this, it says that hardware with the time is going to wear out. As the time comes, it is going to wear out, and this is often called as bathtub curve. At the beginning, there can be faults, right? At the beginning, when I'm creating some hardware, I'm going to have faults, which when corrected and when it reaches to a steady state, then after certain period of services, the hardware will start showing the errors again, and at one time it is going to wear out. So this is called as steady state, where it is going to remain for certain time. Okay, so this is called as bathtub curve. Let's go ahead. On the other hand, we say that software does not wear out like hardware, but software shows high failure rate at its infant state, means at the initial state. When you were doing your programming at FY level, you were having a lot of errors, lot of problems, right? But as and when you keep on understanding the programming languages, you are going to reduce that failure rates. Okay, then it gets modification and the defects get corrected. Okay, and when it get corrected, it comes into an idealized curve. So this is called as idealized curve. On the x-axis there is time, and on y-axis it is failure rate. Okay, so this is the idealized state, it remains continuously. But if we, when I'm talking about the failure of the software, then the failure will increase according to the time, according to the demand of the customer. Okay, so now it says that it is going to make the software deteriorate due to change, first thing, but still your software will perform the operation as it was performing in the beginning, though it may take time, but then it is going to give you the desired result as it was giving you before also. So this is called as software failure curve, and we have seen hardware failure curve as well. The next is when we talk about custom application. Please understand, the software or the companies do not take the complete package. They said, okay, I don't want, if my college is there and I want only accounts package, then I will go for customization according to my need. So although the industry is moving towards component based construction, most software continues to be custom built according to the need of the client. So most of the software is developed according to the specification of the customer. These are few points, like it can be tailor-made according to the specification. Minimal cost, easy maintenance. Minimal cost means I don't have to buy the complete package. I can buy only a small part of it and go ahead with it. Easy maintenance because small part is there. Integrate multiple processes. I can integrate many processes, which we'll be seeing into coming series. Support, I have to provide the support if I am providing the software. Okay, now let's talk about quick brainstorming question. I want you all to take a piece of paper and pen and write down the answer for it. You need to justify why software does not wear out. Okay, so you can write down in your own points. Next is state characteristics of software. Just state them down. Okay, so let's move ahead. I hope so you all are doing the brainstorming session. Now, what is software engineering? If I talk about definition, it is a systematic approach to the design, development, operation and maintenance of the software system. Okay, so software engineering is nothing but a systematic approach. Okay, then software engineering The primary goal of it is to provide the quality software with a low cost. Okay, software engineering will involve project planning, project management, systematic analysis, design, validation, and management activities. Okay, so software engineering is used, or it is a combination of multiple fields. Okay, there are many authors which have stated software engineering. Just to name few, when we talk about Fritz Bauer, he said that software engineering is the establishment and use of sound engineering principle in order to obtain economical software. Okay, IEEE also stated that it is an application of systematic, disciplined, quantifiable approach to development, operation, and maintenance. Okay, so IEEE, according to it, it says it is an disciplined way of finding or doing your software engineering. Now let's go ahead. The first is need of software engineering. Every organization involved in software development is realizing the importance is given to software engineering. Okay, organizations are being assessed and graded based on software engineering principles being implemented. Okay, if an organization has to survive and grow in the competitive environment, software engineering is going to play the key role to it. The first reason is to deliver the quality product. This is the most important goal for any organization. It will ensure that the software meets all the expectations of the customer. If the customer is satisfied, it can enhance your image of the organization and bring in more growth. Okay, so software engineering helps in achieving this goals. The next is large software. It is normally easier to build a wall than a house or a building. Likewise, the size of the software becomes large. Engineering has to step to give it a scientific process. Okay, so it is going to provide you a scientific process and make your task more easier. The next is cost. Okay, a hardware industry is normally showing its skill, and huge manufacturing has lowered down the price of computers and electronic hardware, but the cost of software remains high if proper process is not adapted. Okay, the software remains high means if I am a company and I have received a project of Java, and I don't have an employee who works on Java. My all employees work on Python. Then what is the cost? I have to train my employees in Java so that they can do the project. So what will happen here? Here you're going to increase your cost. Okay. Next is dynamic in nature. If a software needs to survive into the market, it has to be dynamic in nature. It has to always keep on growing and adapting nature of software. According to it, you're on the environment, depending on the environment, how the user works. Okay, new enhancements need to be done in existing one. This is where software engineering is again going to play the role for it. The next is quality management. Better process of software development will provide better and quality software products. Okay, quick brainstorming. Define what is a software engineering, and the next question is state any two needs of software engineering. Thank you so much. I hope so you have understood today's session. Again, please do those two brainstorming sessions and keep it ready for the next session. If you all have any more doubts, kindly write into the comments. Thank you so much.